Hi everyone, I am Paritosh and with my teammates Sharmi and Bhavana, we have created a multi-agent healthcare fraud detection system which we call MediGuard AI. Healthcare fraud costs billions every year, mostly because detection system is very slow and it is heavily manual. So MediGuard AI makes the process faster and more reliable by using three specialized AI agents that examine identity misuse, billing anomalies, and any factors that could block a patient from being safely discharged. It is built on Google's ADK and Gemini 2.5, giving it the speed and reasoning ability needed for real world hospital workflows. So, let me show you how it works. So here we have some sample patient IDs from the dataset that we have. We use Cynthia to generate the whole dataset, and if we press start analysis, it will do all the analysis from agent 1 to agent 2 and to agent 3. But before that, let me show you the architecture of the whole project. So this is the 5 layer design. The front end, which is built with Next.js, gives users a real-time visual of the agent workflow and updates results as each stage completes. The backend is a fast API service that handles incoming requests through endpoints, and it also performs validation and manages communication with the UI. Once the backend receives the request, the Google ADK orchestration layer takes over. A sequential agent triggers the identity agent first, then passes its output to the billing agent, and finally routes everything to the discharge agent. Each agent follows the same pattern. It calls tools, retrieves structured patient and claim data, uses Gemini for reasoning, and returns a clean JSON response. The tools themselves are implemented as ADK function tools. They load and query patient data, compute claim statistics, uh, check consistency across records, and evaluate whether diagnoses match the reported procedures. All data lives inside pandas data frames that are loaded at the startup, giving the system fast local querying without needing a database. So I will move on to the sequence diagram. The workflow is straightforward. The user enters a patient ID. The front end sends the request to the fast API. The fast API invokes the sequential agent. Each agent runs its tools and performs reasoning with Gemini. Then the results from flow back to the front end, which which displays them progressively so the users can see how the evaluation unfolds. Uh, Going back to the dashboard, looking at the results. So here you can see how the system reasons step by step. The identity and claims fraud agent assigns a fraud risk of score of 80 out of 100. It doesn't detect any identity misuse, but it finds two major issues that raise concern. The first is very large claim of $78,000, which is dramatically higher than the typical average cost of around $3,789 for similar services. The second concern is that the high cost claim has no detailed line items, making the charge extremely difficult to justify or verify. These two signals together push the risk score into a high alert range. Next, the billing fraud agent processes the case. It also assigns a fraud risk score of 80 out of 100. It reaches a similar conclusion. The claim cost is unusually high compared to hospitals' normal billing patterns, and the lack of uh, line item details makes the claim even more suspicious. When both agents independently flag the same issue the same way, It strengthens the system's confidence that this is a legitimate anomaly and not a random outlier. And finally, the discharge blockers agent evaluates whether these findings impact the patient's ability to be discharged. Because the anomalies relate strictly to money and documentation, no medical and not to medical readiness, the agent marks the patient as ready to discharge with zero expected delay. In short, this case shows a strong billing anomaly, no identity misuse, and no operational blockers preventing discharge. So, this was our project. Thank you, everyone.